Strain imaging is currently the most sensitive parameter reflecting myocardial deformation and systolic left ventricular function. And reduced left ventricular global longitudinal strain predicts adverse events, and it helps diagnosing myocardial diseases, and it helps monitor subclinical cardiac disease progression. We analyzed the automated global longitudinal strain in 3 different cohorts. A real-world cohort from Mackay Hospital in Taiwan, which included data from 4,228 participants. We also analyzed AI strain in a core lab echocardiographic study called the PROMISE HFpEF study with 183 patients. And finally, we analyzed regional strain in a study of patients with suspected MI. The method we used in this study was a deep learning-based workflow that consists of 2 modules. First, the conventional 2D echo module, and second, the strain module. The deep learning-based algorithm identified 2D video clips as apical 4-chamber view, apical 2-chamber view, or apical 3-chamber view in an internal dataset and validated GLS externally in these 3 cohorts. And the outcomes included measurements of agreement, that's bias, root mean squared error, and Pearson's correlations. And we also measured the area under the curve to identify patients with heart failure and regional wall motion abnormalities. And after automatically identifying and excluding low-quality images, high-quality 2D video clips are parsed into a CNN model, which traces the endocardial border for each frame. So to conclude the findings from this study, fully automated measurements of GLS and regional strain by this deep learning-based workflow showed good agreement with conventional measurements in a core lab-based cohort and in a real-world dataset. Automated measurements of GLS and regional strain correctly identified patients with heart failure and patients with regional wall motion abnormalities, respectively. And the accuracy was comparable to conventional measurements. So our findings support the use of AI-based fully automated echocardiographic strain imaging in practical settings, as it reduces time spent to perform these measurements manually and really expands the availability and important information that we can get from analyzing global longitudinal strain worldwide.